Hello and welcome to GrossiMath.com, where math is for everyone. Today we'll be solving question 39 from the 2017 Algebra 1 STAAR by hand. So let's get started. Alright, so in this problem what we're going to do is we take a look at our words here, and it says a projectile is launched into the air from the ground. Okay, a projectile is anything that you launch into the air. Can be a rocket ship, can be a boulder, can be a cannonball, can be anything you want. The table shows the height of the projectile h of t at different times. H of t, that's a way of talking about, that's called function notation. And what it means is the height is a function of the time. In other words, if I put in a time, I'm going to get out a height. Or the time is what is causing the height to change. So you can imagine that as the time goes by, the projectile starts going up. And then as the time goes by, the projectile starts going down. So since time is what's basically influencing the height, it's called a function of the time. The height is a function of the time. Okay. So based on the table, which function can best be used to model this situation? So a function, here's our functions, and basically it means, look, we put in a time, we do the math, and we're going to get out a height. Okay. And can be used to model this situation. Okay. Model just means to fit this data. And best is another keyword here. Best basically means which one fits the best. In other words, does it have to be exactly correct? No, because in real life we often do not see things that are exactly correct. Okay. Now it may be exactly correct. It's just saying which one is the best. So if there's a perfect one, we'll take that. And if there's one that's really close and better than the others, we'll take that as well. Okay, so now we can start doing some math. All right, so the first thing we need to know is that here I see these little number 2's in my answer choices, and I know that they're going to be quadratic functions. Okay. As long as the highest exponent is 2, you're going to get a graph that either looks like a smile, okay, and that is a quadratic function, and we call that concave up. And then we also have a frown. This is also the shape of a quadratic function. You can see they're kind of the same shape, but they're just flipped around. And guess what that one's called? Concave down. Okay. And the way my teacher taught it to me when I was younger is that the cave points up or the cave points down. So you imagine that it's a little cave. Okay. And they go into the cave and the cave is pointing up or the cave is pointing down. Okay. So now what I want to do, and the reason I'm interested in that concavity is because here I see that I have some negatives and a positive. And what I'm curious about, see this quadratic term. The quadratic term is the term that has the exponent 2 in it. In other words, that whole little chunk of algebra, that's called a term. Okay? And basically, a term is composed of sign, number, and letter. Okay? And when we have concave up, okay, a term is composed of sign, number, and letter. Sign, number, and letter. When we have concave up, what we're going to see is a positive number, any number you want. Okay, so we'll call that number A. Okay, and then at the end, you're going to see your variable squared. Okay, maybe I could avoid calling that A for a second just to avoid any confusion. We could say it's like a little box or something like that. Okay, so it doesn't matter what you want to put there. Maybe the box is confusing too. Positive, a number, and then your variable squared. If it's concave down, what are you going to see? Well, you'll see negative, a number, and your variable squared. Okay, so here I see a negative, a number, and the variable squared. Negative, a number, and the variable squared. So these I already know. I already know that these will be concave down. Simply because of that negative sign being on the quadratic term. That's what they call it because of the little exponent 2. Well, this one looks like it's concave up. So let's see if we can eliminate what kind of graph is this. Okay, so let's take a quick look at our data here. Okay. And I can see that 3 and 1288, 6 and, okay, 2533. So it's going up. It's going up. And this one actually went up by like twice the amount. So after 3 seconds, it was maybe here. And then it went up by twice the amount. So maybe up here. And then now look, now it went up by another 1200. So let's see, that's pretty steep. So it's still going up. And you can see that if it's going up, well, that means that as far as a projectile is concerned, if the projectile is still going up, we must be at the beginning of its travels. And that means that it has not started to come down yet. So what can I say? Well, this projectile should have a concave down pattern. Okay, so now we're going to take a look at these functions and say, hey, if it's supposed to be concave down, I can eliminate choice D because choice D is concave up based on the little pattern that we just looked at. Okay, so now let me clean some of this up and we'll take a closer look at these concave down functions. Okay, the best way to do this problem, I think, is just brute force, as they call it. I'm going to take my calculator and I'm going to just do the arithmetic with these points and see which one gives me the best possible answer. Okay. So let's see what happens. We'll try each one, but I'll take a little calculator shortcut. It's not really a problem as long as you have a calculator that can do this, but if you don't, you can put in you can just plug the number in. So, well, maybe I'll just do it that way, just so that you can see what I'm talking about. Okay, so negative 0.8 t squared plus 201.1 t minus 21.9. Okay, so what I'm going to do is I'm just going to take this exact chunk of algebra right here, this exact expression, and I'm going to put it in the calculator, but I'm going to replace the letter t with the number 3 because that's the time. But instead of just replacing it, I'm going to put empty parentheses. So let me show you a little zoomed in box of, well, first let's type it in so you can see it clearly, and then we'll show you the zoomed in box. Let's see. So I'm going to type negative 0.8 t, but instead of t, I'm going to put empty parentheses. And then I'm going to put plus 201.1 and then some empty parentheses. And then I'm going to do minus 21.9. You should be able to do this with just about any calculator. Okay. And whoops, I forgot the little squared. There we go. There's the squared. Okay. And what I want you to see is that now I have my function, and I'll show you on the zoomed in screen now. Now I have my function written in the calculator, and I'm going to start plugging in my values. And my first value was the number 3, so I'm going to go ahead and start putting that in. 3 goes into the parentheses that I used to replace the letter t. And right here, I replace the letter t with parentheses with a 3 inside. And I'm going to go ahead and press enter. Well, this says 574, and now that does not seem close at all. So I think that A is probably out. Okay. Now, if you're a real stickler and you just want to be double sure, you can go back and change those 3's to the number 6. That's our second number. And you can see 1155. It's still way, way off. Let me show you exactly why I'm saying it's way off. Let's shut off that screen. Yeah, you can see 574, no. And 2,533 does not match 1155. All right, so we know that we're not looking at the correct answer with A. So we'll try B. All right, so for B, we're going to do the same exact strategy. Negative 0.2 parentheses squared plus 985.6 parentheses minus 0.8, and then I'm going to go ahead and I'll show you the zoom in again just so we can all see this together. And there's the zoomed in, and here inside the parentheses once again I'm going to put the number 3. Again, there are other ways of doing this with this calculator that might be a little bit faster, but I'm interested in showing you a way that works just in case you don't have TI Inspire. This says 2954. Now 2954 is way off. Way off. It's nowhere near 1288. Okay, so, but let's try that number 6 again just to make sure. Now somebody might say, hey, what happened to my parentheses that I put in? And most calculators, if they don't need the parentheses, they'll take them out. But you should always put them in because it helps the calculator to avoid any errors. Sometimes it can get confused, if you will. So here we go, we press enter, and it says 5905, which is nowhere close to my second point. My second point should have been 2500. Let me write those up here so that I can keep that on the screen. Our first point should make, our first value of 3 should give us an output of 1288, and our second value of 6 should give us 2533. Okay, so B is out. All right, so now we're going to try C. Okay, so here I am looking at C. Whoops. There we go. Looking at choice C, I'm just going to copy that function in again. And I believe that C must be the correct answer because I've eliminated A, B, and D. But let's just double check it. Negative 1.9 parentheses squared plus 432 parentheses plus 9. Okay, and now we can do our little zoom in trick. Well, not really a trick, but we can have our little zoom window there. And now we're going to press the number 3 into those parentheses. $12.87. Oh, look how close that is. 1287 is so close to 1288. And let's do the number 6 just to double check it. Whew, 2532.6. So that would actually round up and make 2533. So I see my two numbers that I want. And that means that C is clearly the best answer because we tried a bunch of stuff and we see that it is the best answer. And just to double emphasize the fact that at the beginning we did talk about the fact that the word best appears in the problem. And so therefore we need just the one that fits the best, and that means that choice C is the choice that we will choose for this problem. Okay, so let's go to the web browser and just make sure that that looks correct. Okay, and here I am inside the browser. And I'm just going to click on it and make sure it looks right. Hey, the green check mark. That means that it is correct. All right, so there you go. That is how we solve this question. Today, let's just summarize here. Let's get queued up right there. And we'll take the browser away now. We don't need that anymore. Okay, so today we solved question 39 from the 2017 Algebra 1 STAAR. We also reviewed concave up, concave down, there we go, concave down, concave up, concave down. We reviewed how to make a little sketch of a quadratic graph. We reviewed the quadratic term. We reviewed the word term. We talked about what the word quadratic means. We talked about what a word of function means. So this was a great problem for review. And so hopefully you learned something today. And don't forget to like and subscribe and to click the bell icon. And to visit the website where math is for everyone, www.grossimath.com. Have a wonderful day.